What's up? What's up? It's your man Jimmy Chan here. We're going to be talking about system of linear equations. All right. So the word system just means more than one. All right. So in this case, we're going to talk about specifically two lines, right? And the reason why I know it's two lines is because we're going to talk about two variables. And with two variables, typically we usually talk about x and y. So if you remember correctly, an equation with x and y in it is typically a diagonal line, right? Anytime we have x and y in it is a diagonal line. If it's just x in it, it could be horizontal or vertical. If it's a y in it, only a y in it, then it could be horizontal or vertical. So that's the way we're going to think about this, all right? So what happens if I have two lines? What should I do? Well, I mean, what could happen? If I had two lines, what are the possibilities? So let's take a look. I could have the first case, I'll put down one here. The first case being that here's my two lines. And what would happen is that these two lines will cross at one point, okay? So when they cross on one point, I'm going to have one solution, and it's going to be a coordinate point, not zero, a coordinate point of x, comma, y, okay? So it's going to be a point where they cross, which would make sense, okay? So no matter what method I use, I'm going to be solving for the y, and then using the y to solve for x. For x. So that with these two together, it will be my point. Okay? What's another possibility? The other possibility is if I have two lines that are parallel to each other, right? So if they're parallel to each other, then what? Well, there will be no solution. Okay, so if it's no solution, what happens? Well, what's going to happen is that as I'm trying to solve for x or trying to solve for y, what will happen is that those variables would disappear, would get eliminated, would get canceled out, and all I have is numbers left. So if I have numbers left, I could have a true statement at the end or a false statement at the end. So with no solution, what happens is that my end statement might be something like 0 equals 5. All right, 0 equals 5 is a statement, and in this case is a false statement. And the reason why it's a false statement is because 0 is never equal to 5. All right, so anytime that as we're solving for x or y and we get a false statement, then we know there's no solutions, okay? What is the third possibility? Now I got you thinking, right? You're like, what? There's a third solution? How's that? Well, this third solution is if the two lines are on top of each other, okay? So in other words, it's going to have the same slope and the same y-intercept. So in this case, there's going to be infinite number of solution. Okay, because obviously it's going to be here and 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 so on, right? So there's going to be infinite number of solutions. So what's going to happen with that? Well, the same idea as no solution is going to happen with infinite solutions. In other words, when I'm trying to solve for x or for y, the x and y is going to be gone again. They're going to eliminate each other or just disappear, and I'm only going to have numbers left. So if I have numbers left and I get a true statement like 0 equals 0, right? If I get 0 equals 0, that is a true statement. So that's when I know that it is infinite number of solutions. Okay, so back over here again with no solution. So we know that these two lines are parallel. That means the slopes are the same. However, the y-intercept is different. So slope, same. Y-int, different. Where if they're on top of each other, the slope is still the same, but the y-intercept is also the same. Okay, so that's why I want you guys to remember. All right. So while we're saying that, all right. So what are the two methods we're going to use? Well, there's two possibilities. One is elimination. Now, there's another name by it. It's also called addition. So in this book, they always use it as addition method, and that's why I kind of kept it with the A. All right. And the second method is called the substitution. And there's no other name by that one. Okay. So what I'm going to do is I'm going to present you with a problem, an example, and I'm going to do both methods here. All right, so we're going to use the example x plus 3y equals 4. Oh, sorry, it's negative 4 actually. And 2x plus 5y equals negative 5. Okay, so with the elimination / addition method, addition just means that what I'm going to do is I want to add these two equations, and with adding, I would eliminate one of the variables. So I will either get rid of x or get rid of y. And you're like, well, if I add these two, I'm definitely not going to get rid of anything, because this would be what? 3x plus 8y equals negative 9. So nothing get eliminated. And you're absolutely correct. Nothing did get eliminated. However, the part that you have to understand is we can actually multiply one equation by a multiple, or multiply the second equation by a multiple. And what we want to try to do is get the coefficient of the variable that we want to eliminate to be the same. And you're like, what are you saying? There's so many words there and I don't understand what you're saying. All right, so let's look at it. So what we want to do is look, so let's say I choose to eliminate x. Let's say x. So if I look, that's so small. All right. So let's say I'm looking at the coefficients here. I see a 1 and a 2. Okay. So what I could do is to eliminate x, I will have to multiply the top equation by negative 2, because I need the coefficient to be opposite sign, one positive, one negative, and the same number, right? Or I can look at, if I decide to eliminate y, I can look at those two. Well, you're like, how do I do that? Well, I could multiply the top by negative 3. A top by negative 5, but the bottom by 3. And that will work as well. So what I'm going to show you is I'm going to show you a double elimination, meaning I'm going to eliminate x first, then I'm going to go back and eliminate the y. So this is what it's going to look like. Ready? All right. So my first choice. How do I want to do this? Well, first of all, I'm talking about elimination. So let me rewrite this out here. Okay, so let's say I want to eliminate the x. So I'm going to look at the coefficient. It's 1 and 2. And in order for it to be possible to eliminate, that means the top number has to be negative 2. So what I'm going to do is multiply this top here by negative 2. And when I multiply the top by negative 2, that means I got to multiply every single term by negative 2. Okay, so I gotta multiply every single term by -2, right? So what am I gonna get? I'm gonna get a -2x minus 6y is equal to +8. Okay, and then the second equation I'm gonna leave the same. So that's still 2x plus 5y equals -5. Okay, so nothing has changed there. Now what I want to do is go on ahead and add these two together, these two equations together. What am I going to get? Oop. What am I going to get? I'm going to get, look at the x's. -2x plus a 2x goes away. I'm left with a -1y is equal to 3. So therefore y is equal to -3. So now I got one part of my point that I wanted, okay? So now what I'm going to show you is, like I said, I'm going to show you a double elimination. So what I'm going to show you here, so typically what I can do is just take this y, right? And I can put it into one or the other equation and just solve for x, and I'll have the x. But for the spirit of showing you how to eliminate the y if I wanted to, that's what I'm going to show you. So let me go back here again. Let me rewrite this equation. So this was x plus 3y equals -4. 2x plus 5y is equal to -5. So I want to eliminate x. So I'm looking at the coefficients of the, I'm sorry. I want to eliminate the y. So let's look at the coefficients of the y. A +3 and a +5, okay? So the only thing I can get those two numbers to be together, or the same numbers, would be if I made them both 15, right? But one has to be negative, one has to be positive. So I'm gonna choose to multiply the top by a -5 and the bottom by a +3. And you're like, how do you choose those numbers? Well, I know that the coefficient of the y here has to be the same number but opposite signs, right? So in order for me to get to the same number with 3 and 5, it's kind of like LCDs. So the only number is 15. So I want one to be positive, one to be negative. So I decided the top is going to be negative and the bottom to be positive. And there's nothing wrong with if you decide to do +5 on top and -3 on the bottom. But the 5 and 3 has to be there. But it doesn't matter which one you choose to be negative as long as one of them is negative. So what do I get? So the top one is going to become a -5x minus 15y is equal to +20 because I distributed that through. And the green, I'm going to get 6x plus 15y is equal to -15. Okay, so again, I had to distribute this all the way through. Similarly, I had to distribute this all the way through as well. Okay, so now again, I can add these two equations back together here, and I'm going to get an x, and look at the y's. -15, +15 goes away, is equal to 5. So now I have my x equals 5, my y is equal to -3. So my solution here is that these two lines cross at 5, -3. Okay, so that would be my answer. So that's where they would meet. Okay, so if I was to draw again these two lines, it would meet at 5, -3. So could these possibly come up with fractions? Absolutely. So don't think that if you have a fraction that you did something wrong. Okay, in fact, you know what I should do? I should come over and highlight these two as well, just because I highlighted it there. So again, the left one, I eliminate the x, the right one, I eliminate the y. You do not have to do a double elimination. You can only do you only need to do the elimination once. You can take again, this y value and plug it back into one of these equations, and you can solve for x and then say that's my answer. And you'll get the 5 as well, okay? So you don't have to do it this way. I'm only doing it so that you can see how I eliminate the x versus how I eliminate the y, okay? And you don't have to only multiply by one of the equations. You can multiply both equations, all right? So how do I do substitution? So substitution is the B method. So let me write this down again. It was x plus 3y is equal to negative 4, and 2x plus 5y is equal to negative 5. Whoa, what happened there? That looks ugly. Negative 5. So I want to do substitution. So with substitution, this is what you tend to do. You're going to look at the coefficients and say, which one has a coefficient of 1 or negative 1? And you're like, ooh, look, I have a winner because those three don't, but that one does. So what I'm going to do now is take this equation right here, and what I want to do is solve for x. So I'm going to take that totally separate. So I got x plus, actually, you know what I should do? Let's do it this way. I'm going to take this, and x plus 3y is equal to negative 4. And what I'm going to do is I'm going to actually get x by itself. Okay? So the first thing I have to do is subtract the 3y. So that I have x is equal to negative 3y minus 4. Okay, awesome. So now I got my x value here. Okay, so what I'm going to do is now bring it back over, and I'm going to take this equation here, the second equation, right? So you see the first equation went that way, the second equation is coming down again. So now I'm going to have a 2x plus 5y equals negative 5, okay? Because the x, I already found x, right, and it's equal to that. So that's what I'm going to do. I'm going to substitute this x into the second equation. So I use the first equation to plug into the second equation. So now I have 2 times negative 3y minus 4 plus 5y equals negative 5. So now, if you notice, in this equation right here, what happens? I have no more x's. I just only have y, which is great. It's like, I can solve this. This is no problem. So, but the first thing I got to do is distribute the 2, right? I got to distribute the 2 through. So what I'm going to have is negative 6y minus 8 plus 5y equals negative 5. And this is just like two-step equations. You guys done this before, so I combine like terms. So I get negative y minus 8 equals negative 5. So negative y is equal to positive 3. So y is equal to negative 3. Okay? Oh, look. It looks the same there. Y is equal to negative 3. Amazing. So now I'm going to take what I found here, and I'm going to plug it into one of these two equations here. Doesn't matter which one, okay? But it should be the original equation, all right? So what I'm going to do is I'm going to select the very first one. So the very first one says, so I'm going to take the first equation. It says x plus 3y equals negative 4, right? Okay. Actually, you know what? Let's do it this way. Okay. So I know that y is equal to negative 3, so I'm going to say, okay, x plus 3 times negative 3 is equal to negative 4. X minus 9 is equal to negative 4, so x is equal to 5. Awesome. So again, look, I got my x and my y, so therefore I know my solution is 5, comma, negative 3. Voila. And there is my solution right there. Okay? So which is the same as the other solution. Okay? So one is elimination, one is substitution. So if you notice that I show you both methods, and the reason why I show you both methods is because some of your problems may ask you specifically to do elimination, and some may specifically tell you to do substitution. Okay? So you got to know both methods. You don't have to be comfortable with them, but in order for you to get comfortable with them, you're going to have to do multiple ones, right? Like I can't really do a double substitution to do what I want to do. However, I can do a double elimination to get what I want to get, okay? So I do like elimination way better than substitution, but for some people, substitution seems easier for them because all you're doing is isolating one letter, one of the variables, and plugging it into the other equation. You just got to make sure that you're keeping these separated so that you're not plugging it back into the same equation, right? Because it'll be foolish for me if I took this right here, right? Get x by itself and then plug it back into here. Well, that doesn't really help anything, all right? So I got to make sure that I have the first equation and I'm plugging it back in to the second equation, okay? So that's what you got to make sure that you're doing. You're not using the same equation twice, all right? All right. With that being said, now let's get into the next section here, which is called, it's going to be talking about cost. And that's versus revenue, okay? So what's cost and what's revenue? Cost is the money out of your pocket. In other words, when you start a business, you gotta put money into it, right? So you gotta, rent a building or buy a building. You gotta, start buying stuff, right? Buy the equipment like the fryer or the barbecue or, chairs and stuff like that, tables. So that's all coming out of your pocket. Or even if you do a loan, that's still money out of your pocket. Right? Even investors, same thing. It's still money out of your pocket, really. And revenue is the money you make. Which also means money let's call it going into your pocket, okay? So if you think of it as money going out and money coming in, all right? So the part that you need to understand is that obviously when I start a business, I have to start with some kind of cost. I got to put money down and everything else, right? I got to put money in to buy the tables, the chairs, and everything else. But once I open the business and business start booming, now I'm getting revenue. The money is coming back into my pocket, right? So even after the first month with the revenue coming into my pocket, it doesn't mean that I'm rich, right? Because I already paid so much money up front to start this restaurant. So it's gonna take me some time before I get to a point called a break-even point. Okay, and a break-even point is when the cost is equal to the revenue. Okay, so that's what I want you guys to understand. Now, am I going to do any problems on this? No, but if you put the concept of cost that break-even point is when the cost is equal to revenue, you're going to be just fine. All right. Now, the more important part is going to be where you're like, what? What? There's another piece. So this is the second piece. However, now we're going to go back to system of linear equation. And this cost versus revenue is also system of linear equation, because usually cost, starts at one point in the graph, while your revenue starts at 0 because you haven't made any money. And while the cost, the money that's coming out of your pocket, is getting less and less and less, your the money that's coming back into your pocket is going more and more and more, right? So eventually the restaurant will kind of be able to sustain itself and everything's paid off, and now you're really making money. So this point right here is called your break-even point, okay? So that is where two lines are meeting, hence system of linear equations, right? So I want you guys to think of it that way. And then after this is where you're actually starting to make money, and this is the difference of the money that you're making as you're going. But this break-even point, that means you're starting at 0, right? Really, at that point, you are saying, okay, bills are paid, or I should say everything that you've loaned is paid off, and so everything that you have is what is yours now, right? And any more money that's coming in after paying, lights and gas and AC and all that stuff, the rest of the money is yours, okay? So that's the reason why the cost is still there. It's just less and less and less, all right? So what is the next possibility? The next possibility is if we're looking at system of linear equations with 3 variables. You're like, oh boy, okay? So typically it's X, Y, and Z, and these are going to be kind of weird to you because it's more of 3 planes intersecting. And so we're so used to an x-axis, a y-axis, but now we have a z-axis. So in other words, now this is going to be 3-dimensional, okay? So everything that we see that we write on the board is usually 2-dimensional. But once you're giving it some depth, now it's 3-dimensional, okay? So what happens is that a line in 1 dimension would be just a line. In 2 dimensions would be like a rectangle or a square. But when you go 3-dimensional, now it's like a cube, okay? So it's quite interesting that way. All right, so with that being said, we're not really interested in the graph, we're interested in the process. So let's take, for example, I'm gonna do 2 examples for this, all right? So the first example, in order for me to have 3 variables, or 3 unknowns really, I need 3 equations. So up here, we had 2 unknowns, right? 2 variables, 2 unknowns, X and Y, so that's why we use 2 equations. However, if we were to use 3 variables, now we're gonna need 3 equations. So let's say my first equation is 5x plus 2y minus 5z is equal to negative 27. 3x minus 4y plus 3z is equal to negative 25. And then I have 6x minus 3y plus 6z is equal to negative 30. So your first instinct is, holy cow, I give up, okay? And I want to tell you, don't do that. So here, it's not going to tell you to use a specific method. They're not going to tell you to use substitution. They're not going to tell you to use elimination. You can pretty much do whatever you want to do, okay? So it's your choice, whichever one is easier for you, all right? However, we're going to have to do it a couple of times, all right? So let's take a look here. If I was to look at this, I'm looking at the coefficients again, right? So I'm looking at all the coefficients here of the x's, and I'm looking at the coefficients of the y, and I'm also looking at the coefficients of the z's, right? So I'm looking at all of them, I'm comparing them to each other, all right? So what I'm seeing is this. So what I like is this comparison right here. So it's these two right here. That's not what I wanted. All right, it's these two right here. okay? So what I'm going to do is I'm going to eliminate the y because I saw a positive 2 and a negative 4. Like that's the first thing that came to my eye. Now, is there a wrong 2 equations that you're going to choose? No, there's not going to be a wrong way or a right way, okay? So I'm going to take a look at those 2, and what do I see? Actually, you know what? Let's do it this way. Let's give these some numbers. So this is the first equation, second equation, and third equation. There we go. So I'm going to take the first equation, and I'm going to, let me see, 5x plus 2y minus 5z equals negative 27. I'm going to take the second equation, which is 3x minus 4y plus 3z is equal to negative 25, okay? So I'm going to eliminate my y, so what I'm going to do is I'm going to multiply this top one by negative 2, okay? So when I multiply by negative 2, what do I get? I get a negative 10x minus 4y plus 10z is equal to, what is that, 54, okay? And I'm going to keep the bottom the same, so 3x minus 4y. Ooh, that's what I did not want to do. Notice what happened, right? I shouldn't have multiplied by negative 2, should I? Because look at this, look at what just happened. That both are negative. So that won't eliminate anything. So essentially, I should have multiplied by just a 2, right? So if I just multiply by 2, so let's go ahead and erase this and redo that part of the math. So I should get a 10x plus 4y minus 10z is equal to negative 54. That's what I should get, right? Now, let's take a look at what I would get when I add these all together. So what am I going to get? I'm going to get a crooked line. So let's see what I'm going to get here. So I'm going to have a 13x minus 7z is equal to negative 79. Okay? So that's what I have. So I now have only x and z. So in other words, I eliminate the y. Okay? So now, here is the issue. So this kind of bounds me a little bit, right? And you're like, what do you mean by that? So now what I have to do is look at these again and say, okay, how can I eliminate a y again with the third equation? So I have to involve the third equation. So in other words, over here, I have to involve the third equation, okay? Which is 6x minus 3y plus 6z is equal to negative 30. Okay, so I have to involve that, but should I involve the first equation or the second equation? That's up to you, however you want to do it. So what I'm going to do is I'm going to involve the first one again. Okay, so that is 5x plus 2y minus 5z is equal to negative 27. Okay, you see that? So these are the 2 I'm going to involve. I'm going to just make that look better. Okay, so I got to eliminate the y again because I already eliminated the y here. So therefore, I have to eliminate the y here. So I need to look at just these 2 coefficients right here. I got a positive 2 and a negative 2. Awesome. The signs are already opposite. I just need a common number for 2 and 3 to be. So I'm going to multiply the top one by a 3, and we'll multiply the bottom one by a 2, so that they both be 6's. One's positive, one's negative. So what do I get on the top one? The equation 1 is going to be 15x plus 6y minus 15z is equal to 3 times negative 27. 3 times negative 27 is a negative 81. Okay, so let's see what the bottom looks like. The bottom is going to give me a 12x minus 6y plus 12z is equal to a negative 60. All right, awesome. Those look like really big numbers, huh? All right, so what am I going to get here? I'm going to get a 27x minus 3z is equal to 141, a negative 141. Let's make that more clearer. Okay, so now I'm down to 2 equations. You see that? So I went from 3 equations to now 2 equations with 2 unknowns. So again, I have, so let's write this down here. I have a 13x minus 7z equals negative 79. And I have a 27x minus 3z is equal to negative 141. Okay, so now I gotta go from here and eliminate that one last time, right? So you're looking at it going, wow, my right number keeps on getting bigger and bigger, and these numbers aren't like really that close. So I go, okay, for me, I'd rather deal with a 7 and a 3. They're not opposite signs, so I know that one of them has to be negative. So I'm going to go ahead and do this right here. I know that one of them has to be negative, one has to be positive. Let's make the top one positive. So I'm going to do a negative 3 here and a positive 7 down here. All right? So let's see what happens there. All right, so let's see. The top is going to give me a negative 39x plus 21z is equal to a really big number. Let's see here. We have 79 times, or negative 79 times negative 3 gives me a positive 237. And the bottom is going to be 189x minus 21z is equal to a negative 987. Good thing I gave you guys a nice easy example here. So that should be that. And then I'm going to draw a line. Hopefully not very crooked line. There we go. Let's add those two together. So 189 minus 39 will be what? 150 x. The z goes away. And then this is going to be 750. Negative 750. Okay? So that means I got to divide by 150. And my x is going to equal to negative 5. Just making sure that I got everything right here. It's positive, that's negative, that's negative, that's negative, that's positive, that's negative. I mean, that's positive. Okay, cool. So I got my x. So now what I can do from there is say, okay, so now I have my x. So again, my solution is going to be an x, a y, and a z. Okay, so I got my x. So how do I get my z? Well, I got to plug into one of these previous equations I had. Doesn't matter which one? No. So I'm going to use the smaller of the two equations. So I'm going to use the first equation that I have here. Let me use the green. So I'm going to use this equation right here. Actually, why don't I just do it this way? Wouldn't it be easier if I just did this? It would look prettier, wouldn't it? So I'm going to use this equation right here. So now I have a 13x minus 7z is equal to negative 79. So I got 13 times a negative 5 minus 7z is equal to negative 79. All right, so again, I need 13 times negative 5. So I get a negative 65 minus 7z is equal to negative 79. So I get negative 7z is equal to negative 14. So my z is equal to positive 2. Okay, so now I got my x and my z. Awesome. Right, so I got my x and my z. So I got my x and my z. Okay, so what do I do with the x and the z? Well, I can choose one of the originals. I can choose one of the originals, all right? So it doesn't matter which one. But notice that the difficult part was really the first part, right? There was a lot of numbers. I just had to eliminate, either use 1 and 2, 1 and 3, 1 and 2, 2 and 3, or that's about it. I really don't have many choices, right? So it doesn't matter which pair you use. Bottom line is that you're trying to eliminate the same variable. Then you're down to 2 variables, so you're doing it back to exactly what we first talked about, right? The numbers might get kind of awkward, right? Aquataco. So, but it will come back down, all right? And then now I have my x and my z, so all I need is my y. So what I can do now is go, okay, let me see, which one of these 3 would you rather use, right? So for me, you know what? I'm going to use equation 2. So let me see here. I'm going to go ahead and take this. I'm going to use equation 2 and bring it down. All right. And equation 2 was what? It was 3x minus 4y plus 3z, actually, 3z equals to negative 25. Oops, dang it. I was using this. Equals negative 25, okay? So, let's do this. So I got 3 times negative 5 minus 4y plus 3 times 2 is equal to negative 25. Awesome. So what do I have? I got negative 15 minus 4y plus 6 is equal to negative 25. Combine like terms. Negative 4y minus 9 equals negative 25. I have to add 9, and that should be 16. Yep, so I got negative 4y equals negative 16. So y is equal to positive 4. Okay, so now I have another one here. Let's use, I'm trying to be nice and use something nice. So there we go. So now I got my x, y, and z. So therefore my solution is going to be x, negative 5, comma, y, 4, comma, z, 2. Okay? Unless you want me to change the colors here. So z was green. My y was that color. All right. So there's my x, y, z. So that would be my solution right there. All right. So that's not what I wanted. I want this. So that would be my solution right there. Okay? It seems like a lot of work. Well, it is a lot of work, but again, don't let that overwhelm you. That's no need to overwhelm you at all. All right, just go one by one. All right, easy does it. All right, so the second example I wanted to do, you're like, oh, what are you going to do for the second example? All right, so I'm going to do part of a second example. How about that? So the second example is this. So they're going to tell you to find the quadratic function. Wow. And when they say quadratic function, they're going to also mention y is equal to ax squared plus bx plus c. Okay? So y is equal to ax squared plus bx plus c, which looks familiar, except the y is typically 0, right? But in this case, it's not. So what they might do is give you something, all right? They need to give you something for you to get there. So what you're going to do is say, okay, like this example, what they do is they give you a table. So they put a table over here that is somewhat straight. And in this table, they give you x and y. So what they say is, okay, so I have x's and y's here. And when x is 1, y is 269. When x is 3, y is 211. And when y is 4, when x is 4, y is 134. You're like, okay, so what do I do with this? Well, if you notice that this quadratic function has x's and y in it, right? So, and clearly they gave you 3. So they're saying, okay, create 3 equations with what you know, right? What is given here, right? So that's exactly what you do. You go, okay, sounds good. Let's do this. Let's take this and let's make it green, okay? So let's use the green here. So first it says y, so 269 is equal to my a times my 1 squared plus b times 1 plus c. Okay? All right. So now let's get to the next one. Let's make this, I don't know, let's make it that pretty color. So it says 211 is equal to a times 3 squared plus b times 3 plus c. And then let's make this last one. Let's make it this light blue. I like that light blue. All right, 134 is my y, and that's equal to my a times 4 squared plus b times 4 plus c. Okay, yeah, that's not my one. Okay, so that's what I got here, right? So when you look at that, notice what the unknowns are. It's not about the x and y's. It's the a, the b, and the c are unknown, right? Where up here was about the x's and y's. So you can't always assume that what is going to be the unknown. You got to look at the problem, start the problem, and go, oh, because it's 3 variables that we're talking about here, it's going to be 3 unknowns. And clearly this table is telling you that there's going to be 3 equations. So if there's 3 equations, chances are there's going to be 3 unknowns. So now I got to simplify these 3 equations. So what is this first equation going to come out to be? All right, that's going to be 269 is equal to a, right, 1a, let's see here, plus 1b plus c. Okay, now what is the second equation going to come out to be? That is 211 is equal to, this is going to matter here. 9a plus 3b plus c. And the third one is going to be 134 is equal to 16a plus 4b plus c. Okay, so there's my three equations with my three unknowns. So what do I need to do here? So now what you got to do is the same thing as what you did up here. However, this is much easier because look at the c's. The c's are all the same. So that means I got to multiply one of them by a negative and it will work. So let's call these again 1, 2, this is equation 1, this is equation 2, this is equation 3. So what I would do, look at 1. The coefficients are all 1s. So I'm going to do 1, 2, and 1, 3. Okay? So let's see here. I'm going to go, whoa, seems like so much more room. So I'm going to do 1 with 2. All right? So 1 was, I'm just going to keep it all green here. 269 is equal to A plus B plus C, while the second one is 211 is equal to 9A plus 3B plus C. Okay. And then I'm going to do 1 and 3. So 1 again is 269 is equal to A plus B plus C, while the third one is 134 is equal to 16A plus 4B plus C. Okay? So if you notice that I'm using 1, 2, and 1, 3. Okay? Why did I do that? Here's the reason why. Up here, I'm going to multiply the top, and I can choose which one I want to eliminate, right? So I'm going to eliminate, you guys want to just eliminate C? Might as well, right? So I'm going to multiply the top by a -1, right? I can do the same thing here. Let's both eliminate C on both of these, right? Let's multiply both by -1. Okay, so if I multiply the top by -1, what do I have left? I have left a -269 is equal to -A minus B minus C. And the bottom is going to stay the same. 211 is equal to 9A plus 3B plus C. There's that one. Let's go ahead and finish this before we worry about 1 and 3 here. So what do I have here? What does green and maroon make? We'll just, I'll call it purple. Why not? Okay. Oops. Keep that. And then bring this down. So I got 269, 211. So I'm going to get a -58. Wow. It's like my pen is leaking, which is not possible. Okay, and that's going to equal to 8A plus 2B. And the C is gone. Okay. So now let's worry about this one. I'm going to multiply the top by negative again. So what does the top get me? It's going to give me -269 is equal to -A minus B minus C. The bottom stays. 134 is equal to 16A plus 4B plus C. And what does that give me? Right? So that, let me see, what color should that be? We'll just make it orange, just for orange sake. All right? I know it doesn't really work. So I got the 269 and the 134. So I get we said orange, okay. So we're going to have a -135 is equal to 15A plus 3B. C goes away. Awesome. Now I'm down to 2 equations, 2 unknowns, right? So let's write those 2 down. So I got -58 is equal to 8a plus 2b, and I have negative 135 is equal to 15a plus 3b, okay? So, what do I want to do? For me, I know that 2 and 3 can be common pretty quick, and that would be 6, right? But I need one to be positive, one to be negative. So let's do, and it doesn't matter which one you multiply by which. So I know that I got to multiply both of them. One of them has to be negative. So I'm going to multiply this by 2 and this by 3 because 3 times 2 would give me 6 and 3 times 2 would give me 6 and 2 times 3 would give me 6. But one of them has to be negative. Question is, which one do you want to be negative? I'm going to go ahead and make the top one negative. And you're like, why? Why the top one? Why not the bottom? You can. It doesn't really matter. Just one of them has to be. Okay? So now I got to again look at 58 times 3. And I get over here. Let me see here. I'll keep it blue. Why not? I'm going to have a positive 174 is equal to negative 24a minus 6b. And the bottom one is going to give me 270. Negative 270 is equal to 30a plus 6b. Okay? What the? Yep, okay. So now, I'm going to add these two, and what do I get? Let me see here. I'm running out of colors here. I guess I'll use the red. Okay. So what do I get? I got the 270 and the 174. So I'm going to get a negative 96 is equal to 6a. So a is going to equal to negative 16. Okay, so there's my a. Okay, so I'm going to put a little bracket here so I know exactly where they are. All right, so I got my a. I got to find my b. So I'm going to take, I'm going to take this equation. I'm going to use that equation here. I just wish I wish I had better penmanship because I don't like that. Okay, I'm going to use that over here. All right, so I got negative 58 is equal to 8a plus 2b. Okay, so let's do it. Negative 58 is equal to 8 times negative 16 plus 2b. So I got 16 and 8. Awesome. So I have negative 58 is equal to negative 128 plus 2b. So 2b is equal to, I got add, so we're going to be positive 70. So b is going to equal to 35. So I got my second one. Awesome. Now I got my A and B. So the question is, which one of these originals do I want to use? If I were you, I don't know why I would not use the very first one. Because A and B and C, I don't have to multiply by anything, right? So all I got to do is just kind of combine them. So me personally, just me, I will use that very first equation. That very first equation. So let me see if I can draw this nicely. Whoop. Okay. So I'll use that very first equation, which was 269. Okay. So it's going to be 269 is equal to A plus B plus C, okay? So there's my A, my B, and then my C is still green. So now let's plug it in. So I got 269 is equal to negative 16 plus 35 plus C. So I have 35 and 16. So I got 269 is equal to 19 plus C. So I got to subtract the 19, so C is going to equal to 250. All right. So now here is where you might want to say, oh, I got it. Oops. I got it. So the solution must be, negative 16, comma 35, comma 250. No, not right. Okay? That's not true. Because the original equation said what? To find the quadratic function, right? And it gave me exactly what has to be laid out. Y is equal to A, x squared, plus bx plus c, which I have the a, b, and c down here. So my solution here is going to be y is equal to negative 16 x squared plus 35x plus 250. Do you see that? Okay, so if you look at this right here, it says ax squared plus bx plus c, right? And the y there. So this is my quadratic function. So this right here would be my so-called solution. Okay? So you gotta be careful. You gotta know, hey, when am I gonna give a point versus I have to substitute things back in. So how do you know? You're gonna be given something like this with a table, all right, or information of like some kind of input and some kind of output, x's and y's, right? So that in that case, if you're given a function that you have to fill those spots in, those coefficients in, then your answer is going to be actual function. While here, you're only going to be given 3 equations, okay? And they're saying, hey, find the value of x, y, and z. Then you have to just give me a point, all right? So I know this is a long video. These are long notes. So hopefully you understood everything. If not, you know how to get a hold of me. Talk to you later. See ya. Bye.